Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, let's look at the first question. Okay, the thermometer in diagram has no scale. Before this thermometer can be used to measure temperature, two standard temperature known as fixed points. Okay, fixed points are needed. These are labeled X and Y. Okay, so okay, the question asks which row describes these fixed points on the Celsius scale. So this question wants the description of the two fixed points. So if you recall back thermometer topic, okay, fixed point, this is upper fixed point, this is lower fixed point. So hopefully you remember how to carry out experiment or activity to calibrate the uncalibrated thermometer. So X is upper level. So for this one, if you remember, so this you place the thermometer at the above the surface of water so that it measures the temperature of the steam. And here you place the thermometer in ice. Okay, so that's how we get the two fixed points, right? So X is the upper fixed point, therefore you see temperature is the temperature of pure X, upper, pure boiling water. So this one, these are not the answers. So we have two possibilities. And then Y is the lower, so temperature of pure melting ice. Okay, so the answer is B. That's correct. Okay, next question. When a hot gas is left to cool, its internal energy decreases. What causes this? Questions. Hot gas left to cool. And then internal, there is about the question about asking about internal energy, and it says here decreases. Okay, that's correct. What causes the internal energy decreases? So it is because a decrease in the kinetic energy. So that's the answer. Okay, so if B, a decrease in the gravitational potential energy, okay, this one is not related. Okay, and then an increase in the average speed. Okay, average speed increase, that means it becomes hotter. So that is not correct. An increase in the average distance. Average distance means it gains energy. Okay, so that's also wrong. Okay, let's look at question number 3. The diagram show 4 blocks of steel. The blocks are all drawn to the same scale. Okay, the same quantity of thermal. Okay, now thermal energy is given, is applied, and the values are the same. Which block shows the greatest rise in temperature? So in this topic, okay, there is a relationship between mass and heat capacity. Then mass and the rate of heat absorbed. Okay, so because okay, we have A, B, C, D, and then they are drawn into in scale. Okay, so this one is considered the largest, and this is the smallest. So greatest rise, okay, so last time we learned about ni. Okay, we have water in a bucket, and then we have water in a pool. So after 1 hour, this one the temperature higher. Okay, this one same water, temperature lower after 1 hour. Okay, why is that? It's because of its mass. This one has low mass, therefore the rise in temperature higher. So the answer is A, 3A. Okay, so let's move on to the next question. One ice cube is placed on a metal block. Okay, an identical ice cube is placed on a plastic block. The blocks are left next to each other on a table in a laboratory. Okay, which ice cube melts first and why? Okay, so this one, okay, very easy. Okay, this is about heat transfer. So we have different materials here. So one is a metal block, one is a plastic block. What do you know about them? Okay, you learned this one during Form 1. Okay, so recall back, read back your notes. Okay, watch again the videos. So metal, okay, is a good heat conductor. This one, poor. Okay, plastic is poor. So which one cube melts first? So A, the ice cube on the plastic block melt first. Is that correct? So that is wrong. Okay, because it is a insulator. So it is not a good heat conductor. Okay, right. The ice cube on the plastic block melts first because a good conductor. So this is wrong. Yeah? The statement is itself is wrong already. And then C, the ice cube on the metal block melts first. Okay, so that is correct because metal is a good conductor. Yes, that's the answer. Okay, so number 4, C. D, the ice cube on the metal block melts first. Okay, that's correct because metal is good insulator, so that statement is wrong. Okay, number 5, the freezers X and Y are identical except that one has a door opening at the front and the other has a door opening at the top. Both doors are the same size and are opened for the same amount of time. Which freezer gains the least amount of thermal energy in this time and why? Okay, so this is about heat transfer. Okay, freezer and door. So what's the difference between diagram X and Y? They are identical, except that, so here the opening is the front, this one is at the top. Okay, which freezer gains the least amount of energy? Okay, so if you look at A, freezer gaining the least thermal energy, it says X. Why? Cold air falls. Okay, what does that mean? So this one, okay, freezer. So the freezer here, so cold air fall down and goes up. Okay, here freezer and cold air will go down. So goes up. Something like that. Okay, so reason cold air falls. Okay, that is correct. But it says freezer gaining the least thermal energy. EX. Okay. Right. So KIV that one. B. Freezer gaining the least thermal energy. Reason warm air falls. Okay, this statement is wrong. So B is not the answer. C. Freezer gaining the least thermal energy is why. Okay. Okay, and then cold air falls. Okay, this statement is correct. Okay, warm air falls. Okay, this statement is wrong. So, now, A or C? X or Y? Now, what you, okay, this one, you read again. Both doors are the same size and opened. Okay, imagine when you open the door. Okay, you open the door. So, when you open the door, heat will enter. Okay, this one heat will enter. Okay, freezer gaining least thermal energy. Now, when heat enters, okay, so the cool, right? So only this part here. So this one, the answer is X or Y. So the answer is C. Y. Gain the least thermal energy because the opening is at the top. The cold air falls. Okay, so that's why the answer. Okay, number 6, again about thermometer. The diagram shows a liquid in glass thermometer. What is the temperature difference between the two fixed points on the Celsius scale? So this is not difficult. Okay, when you learn about liquid in glass thermometer, okay, we have lower fixed point, we have upper fixed point. The question asks you, what is the temperature difference between the two fixed points? So you just minus them off. 100 degrees Celsius minus 0 degrees Celsius, that gives us B. Okay, so as simple as that. So it will be simple if you know which are the fixed points. Okay, 17. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into warm surroundings. Which statement about the metal block is correct? So we want correct statement. Okay, the internal energy of the metal block increases. Okay, so here it looks like, yeah, maybe, because now we say from cool to warm surrounding, from cool to warm. So there is a temperature increase. Okay, internal energy. When we talk about temperature, remember, temperature is related to kinetic energy. And kinetic energy is when we talk about internal energy of the particles. So, okay, A looks good. Okay, now let's just check B. The temperature of the metal block decreases. Decreases is wrong because we move it to a warm surrounding. Convection transfer energy throughout the metal block. Is it convection? So convection is about fluid, okay? And remember, fluid is about gas or liquid. So is there any gas or liquid? So this is about metal block. Okay. So the metal block. So the metal, okay, so this is not correct. The metal contracts slightly. So that's wrong because it becomes warmer. So it expands slightly is the correct one. So the answer is A, 17A. Okay, so this is quite similar to the one that you have, but now this is a radiator. A room is heated by a radiator. The diagrams X and Y show two possible circulations of hot air which heat the room. So these are rooms. Okay, radiator, diagram X. Okay, what's the difference? Okay, so the difference we can see, so ceiling, floor. So the only difference is the direction of the movement of air. Okay, circulations of hot air. Now, which diagram and reason explain the heating of the room by convection? So this is convection, but which is the correct one? Okay, so you need to know for a convection, okay, from the source of heat. So radiator is the source of heat. So the heat is from radiator. So the heat must travel from heat source and then moves up because it has less density, and then cool air will go down and this continues. So that's how we get convection. So X is correct, not Y. So we are left with A or B. Okay, air density decreases when air is heated. Okay, so I told you just now. Okay, right, so the answer is A. So very easy questions. Two similar liquid in glass, again another thermometer question. Two similar liquid in glass thermometers P and Q are placed in direct sunlight. The bulb of thermometer P is painted white. Okay, so this is about heat transfer again. Okay, P is painted white. The bulb of thermometer Q is painted black. Okay, so Q black. How and why would the thermometer readings differ? Okay, so A, P would read higher than Q because black is good absorber of radiation. Now, which one is correct? Which statement is so this we have two parts here. Okay, P would read higher. So is that correct? So that is not right. Although it's true, black is good absorber of radiation. Okay. B. Okay, so since black is good absorber, so black Q should have should have higher temperature. Okay, so A is wrong. B. P would read higher. Again, this is wrong because Q is black and black is the good absorber. So here, okay, the statement itself is wrong. Black is poor absorber. Okay. C. P would read lower. Okay, so this is true because black is good absorber. This is also true. So C is the answer. So let's just check D. P would read lower. Betul, good. Because black is poor, so that is wrong. So Q is, C is the best answer. A sealed box contains a fixed mass of gas, which action results in each molecules of the gas colliding with the walls of the container less frequently and with a smaller force. Okay. Alright, which action, okay, results in each molecule of the gas colliding container less frequently. So if particles gain energy, so it will have high temperature and collide more. So but this one less frequently, so it's about energy loss. So decrease the temperature of the gas. Okay, so this is about energy loss. Okay, decrease the volume. Okay, this one has nothing to do. Decrease the volume of the container. Okay. Colliding with the walls. Okay. So here smaller force is there. Increase the temperature of the gas. So if you increase the temperature, it gains energy and it collide more frequently. Increase the volume. So if you increase the volume, okay, it will colliding with the walls of the container less frequently. Okay, but now it says about smaller force. Okay, so the best answer is A. Okay, it's about the temperature. Right, we want to talk about when we talk about energy, we work less frequently, so it's about energy loss. Okay. Okay, so let's choose questions. Okay, which question do you think you want? Okay, this is another example question. A gas is heated in a sealed container. The volume of the container doesn't change. So now, volume constant. What happens to the molecules of the gas? Gas is heated, that means temperature high. So we learn about PVT, remember? Okay, so now V is constant. So there is a relationship between pressure and temperature. So but the question asks you about the molecules. Okay, so average distance between molecules increases. Okay, gas is heated. Okay. B. So now the volume doesn't change. So we have same volume, but you increase the temperature. So the average kinetic energy of the molecules increases. So again, okay, when we talk about temperature change, okay, then kinetic energy will change. So here increases. So this is the best answer. Okay. Water in a beaker evaporates when left on a bench for a period of time. Which three factors all affect the rate of evaporation of the water? So this is about evaporation. Okay. This is also what you have learned last time during Form 1. So what are the factors? So wind speed, okay, true. Surface area. Temperature B. Oh, this one should be down. Temperature. Is it temperature? Okay, also correct. B. Wind speed. Temperature. Okay, volume has nothing to do. Oh, all the answers has volume. So the answer is only A. Very easy. Wind speed, surface area, temperature, and the other one should be humidity. Okay. Now, a solid, next question. A solid is heated, causing it to expand. What effect does this have on its mass and on its density? Okay, mass is about the quantity of matter in an object. So, mass will not change if you don't change the amount. Okay, so if you, now you just heat it. Okay, you don't add the number of particles on the, okay, it's still the same. Okay, so the mass will not change, but the density, okay, so when it expands just now, is this, so the same mass over volume, so that is the density one. When it expands, okay, when it expands with same mass, okay, same mass, okay, now we have volume 2 which is higher. So now you see the relationship between density and volume is inversely proportional. That means when you increase the volume, the density decreases. So the answer is C. Okay. Which row describes the forces between the molecules and the motion of the molecules in a solid? So solid, okay, the molecules are not moving. They just vibrate. So answer A and C is wrong. Okay, you can just remove. Okay, they don't move. So A or a B or D. Okay, B, forces between molecules strong. Yes. Okay, they are in lattice, close to each other. I hope you understand what's the meaning of lattice. You learn that in chemistry, kan? Okay, right? They have strong bonds to each other, so that's lattice. Okay, strong bonds. So B is the answer. Wet cloths are hanging outside to dry, which condition decreases the rate of evaporation. So this is about rate of evaporation. So just now we talk about the factors. Okay, the factors is the surface area. So if you folded the clothes, okay, that means the rate will decrease. So now the question 1, decrease the rate. So A is the answer. Let's just check B, higher temperature. So the higher temperature will cause high rate of evaporation. Wetter the clothes, okay, this is not related to the factors. Windy day will increase. So A is the answer. Again, thermometer. A diagram shows a liquid in glass thermometer. Okay, so look at the diagram. Okay, read all the label, capillary tube. Okay, so okay, although you read this one, sambil-sambil tu study lah. So that is what we mean as capillary tube. And then the stem, the whole body. Okay, and glass bulb, and that's liquid. The design of this thermometer includes the following features. Okay, number 1. A liquid which expands linearly when is heated. Okay, is that true? Yes, we want something that expands linearly so that we can read the scale. And a glass bulb which has thick glass wall. Do you want a thick glass wall? and a capillary tube which is very small diameter. Why? Why do you want it to be small? Okay, is that true? You want small or you want bigger one diameter? So which features increase the sensitivity of the thermometer? So this is the factors to increase the sensitivity of a thermometer. Which one is correct? Okay, so this question, okay, if you want to increase the sensitivity, number 3 is the only one that is correct. Okay, so correct. So answer D. Number 1, liquid which expands linearly. Okay, that is true, but that doesn't affect the sensitivity. Sensitivity means you want it. Okay, what is the meaning of sensitivity? Sensitivity is the ability. It's the ability of an instrument to detect the smallest changes. Okay, so if you have narrow capillary tube, so slight change will cause the liquid to rise more. Okay, so this is the answer. Move on to the next question. 4 different metals. Okay, now underline different metals. So they are different things. Different metals mean this one has different C1, capital C2, different capital C3, and different C4. Okay, and are given same quantity of thermal energy. So same quantity of thermal energy. So what's the symbol? This one, symbol Q. This one. Okay, so same Q, 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 Q. So Q is the heat provided. Okay, which block has the greatest thermal capacity? So remember in topic thermal capacity, C is equal to what? Okay, energy equals to change of theta. C. Can? Okay, I use capital C. Okay, capital C to because this is thermal capacity, not specific capacity. Specific capacity, no. Okay, so this one, therefore, C equals to Q over change theta. I just rearrange this one. Okay, now we want to look at I draw the C bigger. Okay, so now, okay, this is not specific capacity. So what's the relationship between the temperature change? So you know heat energy is constant. So there is a relationship we want to look at between C and then the other variable is change of theta. So from this equation we see that relationship is change of theta di bawah, bottom. So that means what to write here? You write 1 because this is relationship. Therefore, the relationship is inversely proportional. What does that mean? That means if the temperature change is high, the specific capacity is low and vice versa. So which one is the gives you the answer? Okay, so we want, but this one, which block has the greatest thermal capacity? So we want C high, so the temperature change must be low. So this one 4, 3, 2, 1. So this is the lowest. So that's the answer. Okay, 22A. Do you understand? Okay, if you don't understand, you can write in the comment or you can PM me, okay, to explain more. So I think this is I have explained detail to you. Okay. Next, a solid heater is heated from room temperature. The graph shows how its temperature changes with time as it is heated constantly. So this is a heating curve. You learn about heating curve. Okay. Under the topic of latent heat, specific latent heat. Okay, the graph show how its temperature changes with time as it heated constantly. So heat is provided. At which time has it just become complete liquid? So for this one, you need to remember we have a few regions here. Room temperature. So this is a solid, okay, at room temperature. So this is when it is in what? It is in solid. Okay, this is in solid. Okay, it's on solid. Okay, and then at this point, okay, this is the first point you see it melts. Okay, so this is the first point you see liquid. The solid has liquefied, and then actually here you see from here A to B, you see a few liquids and you have a few solids. So this is the melting point actually. Okay, the value here. So whatever the value here, degree Celsius, that is the melting point. But that is not the question. The question asks you when becomes completely liquid. So not A, okay, but at B. What about B? So at B also, it is still melting point. And now, if you look at the temperature, so you have same temperature from A to B, B to C. So actually, here also, right, you have liquid and solid. So I just move this one. Okay, liquid and solid. Oops, here. Okay, liquid and solid. Okay, this region. Okay, and then at C, okay, now after C, the temperature rises. So, means this one is the moment when you get it completely liquid. Okay, and what happened is the temperature increases. So, the answer is yes, C. Right? Okay. Rods of the same shape and size are inserted through corks into a tank of hot water. Each rod is covered with a layer of solid wax that has a low melting point. After a period of time, some wax melts. On which rod will the wax melt first? Okay, so this is about heat absorption, or this is about conductor. So which one is, on which rod will the wax melt first? So the question wants melt first. So we have different materials. Good thermal conductor, bad thermal conductor, moderate. So of course lah, the good thermal conductor will enable the wax melt first, because so if we have a conductor, when it conducts heat very good, it will absorb the most heat. So that will cause the wax melt first. So B is the answer. Okay. Okay. Now, which topic is this one? A boy jumps into an indoor swimming pool. He notices that the water appears to get colder as goes deeper underwater. This is due to convection. Which statement is correct? Okay, A. Cold water is more dense than warm water. Okay, we mentioned this one just now. When we talk about the freezer. Okay, it's when we talk about the cold air last time. So the same for cold water. So because it is cold water, so it is more dense than warm water. So this is correct. So it sinks. This is also correct. Okay, denser object will sink, and less dense will rise. So A may be the answer. B, warm water is more dense. Okay, that's wrong. The molecules in cold water have more, it's cold water. So when we talk about in terms of kinetic energy, it has less, not more kinetic energy. So C also wrong. The molecules in warm water are closer together. No. Okay, when they are warm, okay, it gets energy, so they try to break the bond, so the distance between molecules becomes bigger. So the answer is A. Okay, so this is about specific heat capacity. Okay, question number 26. The specific heat capacities of aluminium, iron, ethanol and water are given. Okay, so these are the values. You see they have different values. 1 kg of each metal. So here there is a statement about 1 kg of each metal. So this is about specific heat capacity. Is put into 5 kg of each liquid. The starting temperature of each metal is 60 degrees Celsius. So the initial temperature is 60 degrees Celsius. The starting temperature of each liquid is 10. Okay, so we have liquid here. So initial liquid temperature is 10 degrees Celsius. Which example has the highest final temperature? So that means highest final temperature, that means it wants to tell us, okay, so the temperature change high. So if there is the high temperature change, that means, okay, if we have this if you remember this equation, this is okay, and then if we have specific capacity, the equation is Q over M change of theta, right? I'm just rearranging the formula. So when we have highest final temperature, that means we have low specific heat capacity. So which one? So this is the concept that you need to understand. If you don't know this concept, you may not be able to answer. Okay, you will be guessing the answers only. So which one? So we just look at this. Iron has less specific heat capacity. Okay. Alright, so okay, we have iron or aluminium or iron. Okay. Highest final temperature. And then liquid, we have, which one has low specific capacity? 60 degrees Celsius, and this one 10 degrees Celsius. Which object, is it liquid transfer heat energy to solid, or solid transfer more heat energy to the liquid? So of course, if you look at the temperature, the solid has higher temperature. So when you place the solid into the liquid, so the heat from the solid transfer to the liquid. So that means the liquid will absorb more heat. Liquid absorbs more heat, so that it will has highest final temperature. So we want ethanol. Okay, because ethanol has lower specific heat capacity. Okay, therefore it will absorb the most heat. Okay, and the final temperature of the liquid will be high. Now, is it aluminium or iron? Okay, for this one, okay, we don't want, okay, which one, which object will have higher specific capacity? So for this one, we don't want to talk about the final temperature of the how do you say? Okay, so this one also, this is a bit tricky. So just now I told you, if the specific capacity is less, so it will has higher temperature. But remember, this one, this is some what we call is as, you can say that the metal, the solid, the object, the solid, the substance, okay, this provides heat. So this is the heat source, right? So if it has lower specific capacity, so let's say lah, the specific capacity is 450, which is low. That means it is what is the meaning when what do you understand when you say C specific capacity is low? That means it heats up fast and it cools down fast. Do you understand what I'm trying to say? So if it cools down fast, so the final temperature will be very, very, very low. Kan? So let's say is this C1. Okay, we'll talk about this one. So the temperature final of the solid will be very, very low because it will cool very fast. So let's say you will get it becomes let's say, what's the value? Let's say 25 degrees Celsius. So that's low. If we have, okay, let's say we have substance 2. So now C equals to 900. Okay, the initial is 60 degrees Celsius. So 900 is slightly higher. It's higher than 450. Therefore, it heats up quite slower than substance 130. And it cools down slower as well. Therefore, the final temperature is not as low as 25. Maybe you get this one, 35 degrees Celsius. And the question asks you, okay, which example has highest final temperature? So it's ethanol because it absorbs more. So the answer for metal must be aluminium. Okay, because it has higher specific capacity, and therefore the temperature drop is not as much as iron. Okay. Alright. So let's choose. Okay. Questions. Okay. A teacher shows his class a polystyrene cup. Okay, the cup is made of thick plastic and lots of tiny air bubbles. Okay, there is something it wants to see here. There is air bubbles in it. So this is the plastic cup. So lots of air bubbles. Okay, he asked the class why the cup is so good at keeping a hot drink warm. 3 suggestions are made. It contains air, which is a poor thermal conductor. The air is trapped in tiny bubbles, so very little convection is possible. The plastic is a poor thermal conductor. Which suggestions are correct? So the students, they teacher ni. So but which statements are correct? Okay, so the answer is, okay, number 1, it contains air which is poor thermal conductor. Is it true? Air is a poor thermal conductor? Yes, it's true. Number 2, the air is trapped in tiny bubbles, so very little convection is possible. Okay, so this one, right, very small. Okay, so little convection happen because it's a fluid. It's an air, but little convection is possible because the bubble is tiny. Okay, so that's true. The plastic is poor thermal conductor, of course, that's true. So the answer is 1, 2, 3. Okay, D is the answer. Okay, the diagram shows 4 labeled changes of state between solid, liquid and gas. Okay, changes of state. Okay, from solid to liquid P, liquid to gas Q, and gas to liquid R, liquid to solid S. Which changes need an energy input? Okay, so you must understand this situation. Okay, so P, solid becomes liquid. So here solid, okay, we know it is close together and it has strong bond. So in order to break the bonds and becomes liquid, you need to, yes, provide heat. So heat is absorbed here. So energy input, yes, P ada energy input. Now at Q, from liquid to gas, okay, so this one, the distance even further away, so this is also heat input. So Q. So which needs an energy input? So Q and R. Okay, no Q, no Q. Oh, but this one has P. So P and Q is the answer. Okay. Q and R will be R and S. Here R, so that's wrong. Okay, so this one, heat is released to form the bonds. Okay. Now, a driver of a car measures the pressure of the air in the tires. He measures the pressure again after a long journey. The pressure reading has increased. So we have two situations. Situation 1, pressure low. Situation 2, pressure high. Pressure increased. Which row states what has happened to the speed of air molecules and the temperature? When pressure high, that means temperature increases. Okay. Why? Because there is friction. Okay, when there is friction, okay, so the temperature will rise. Okay. Okay. So speed, when temperature increase, the speed the molecules will gain kinetic energy, and of course the speed of molecules will increase. So A is the answer. Or temperature increase. So D is the answer. Okay, so this is in topic. Which one? PVT. Okay, so this one is Gay-Lussac's law. Okay, pressure law. Alright, some water in glass flasks is gently heated. Why does the water level in the glass tube rise during heating? When you heat the water level rises. So this is very easy. It's because the water itself expands. Only the glass flask expands. The word only makes this wrong. Okay? Everything will expand when it is heated. Only the water expands, also wrong. The glass flask expands more than the water. Is that true? But the question, why water level increases? If the glass flask expands more, so the water level will maybe stay the same. Okay, so the answer is the water expands more than the glass flask. That's why. Okay. Okay. So let's. Okay. Next question. Question number 33. A fixed mass of gas is trapped in a container. Okay. So the first sentence already gave us ideas. This is about gas. Okay, gas laws. Okay, fixed mass of gas trapped in a container. The temperature increase. So variable 1 is temperature, but the volume is kept constant. So volume constant. So so let's recall we have PVT, this triangle. Okay, so once you see fixed mass, okay, something as a variable is kept constant, then you immediately needs to recall this triangle. Okay, now since V is constant, Okay, V constant. So the relationship is about P and T. So what's the relationship? The formula is P over T. But the relationship, so this is the formula. So the relationship P equals to KT. So the relationship is directly proportional. Okay, so let's go back to the question. How does the change affect the kinetic energy of the molecules and the pressure? So from the equation, sorry, this one is pressure. So from the relationship, higher, okay, temperature increase. Okay, the higher the temperature, the higher the pressure, because the relationship is directly proportional. So pressure increases. Okay, so we cancel C. Now, next, kinetic energy. So I always tell you, when there is temperature change, we will have change in kinetic energy. So here temperature increase, so kinetic energy will increase. Decrease is wrong. So the answer is A. Okay. Next. Okay, this is easy. You know that. What are the fixed points? What are the answers? What are the answers? Okay. Okay, so this is the range. Okay, but they are not the fixed point. So the fixed point is 0 and 100. Okay, because this is the upper fixed point, which is the boiling point. So 0 is the lower fixed point, which is the melting point. Question 39. One end of a rod of copper is placed in hot water. Thermal energy travels along the rod to make the other end warmer. Okay. So this is not about thermocouple, yeah. So imagine this is a beaker, one end of a rod of copper. So I have a copper rod. Okay, so this is hot water. Okay, and thermal energy travel. Okay, so this is hot water. The energy travels along the rod to make the other end warmer. So here, it becomes hotter. Okay, now thermal energy travels along the rod to make the other end warmer. Okay, now what is the behavior of the copper at an atomic level? Okay, so we are going to explain about the atoms in the copper. Okay, for atomic level, that accounts for most of the transfer of thermal energy. So this is about heat transfer, not about thermocouple, yeah. So atoms of the hot end gain kinetic energy. Okay, right. So what is wrong with this statement? Okay, so here it says atoms at the hot end gain kinetic energy and move, the atom move towards the other end. Is it true? The atom here moves to the other end. If the atom moves to the other end, that means there is no more atom here. Maksudnya dia terurai ke apa? So that this one is incorrect. The statement is not correct. Then B, atoms at the hot end expand, colliding with other atoms and transferring energy. Okay, right. And then okay, KIVB, free electrons. See, free electrons at the hot end gain energy. So what's the difference between B and C? Okay, hot end, okay, gain energy. Okay, alright, so this one is talking about atoms, okay, B, but C is talking about free electrons. So which one is the best one? So of course the best one is free electrons. Okay, because this is a metal. Okay, copper is a metal, so it has freely moving electrons. So the free electrons that gains energy, and that free electrons are those who move towards the other end. Okay, and colliding with atoms along the road. So the answer is C. Okay, now what about why D is wrong? Free electrons at the hot end gain energy from the hot water and move directly to the other end. Okay, no, right? So it doesn't move directly, okay? It collides with atoms along the road. Okay, now 40. A bubble of air of volume 3 millimeter cubic is underwater. Okay, so you see what I did just now. I drew this diagram. So for this question also, okay, you can just sketch, okay, in order to help you understand the situation. A bubble of air of volume 3 millimeter is underwater. So this is water. So this is bubble. So the bubble is 3 millimeter cubic. So this unit tells you this is a volume. Okay, so that this is the volume. So the volume is 3 millimeter cubic V1. Okay, and the bubble is at a depth where the pressure, the air inside the bubble is 4 times of atmospheric pressure. So now it is, it has a depth, okay, a certain depth. Okay, we don't know what's the depth. The pressure inside the bubble, now there is pressure. So I just call it pressure 1, volume 1. Pressure 1 is 4 times atmospheric pressure. So I use this symbol. Okay. The temperature of the air bubble stays the same. So temperature stays the same. Okay. So remember this. So this is about Boyle's law. Okay. Temperature is constant. So now, so we are expecting to have V2 and P2, right? Situation 1 and situation 2. So what is the volume of the, so this is the question. What is the volume of the air bubble as it reaches the surface? Here is the surface. Now, so now you need to understand this, okay? Atmospheric pressure. So atmospheric pressure is pressure of the atmosphere. So where is the atmosphere? So here. So these are gas, air. So air here has the pressure. So now I use the symbol PATM to represent the value of the pressure of atmosphere at the surface ataupun above the water. Now, under the water, it depends lah. So, for the first situation, it says the pressure is 4 times PATM. So, now we have an expression for the pressure. Okay. So, we treat this as value lah. So, but now it doesn't give us the value. Kita macam ada algebra kat sini. So, it's easy. So, now you know this is PATM. So in order to get V2, what formula do you know for this one? So look at this triangle. Okay, so P and V next to each other. So P times V. So P1 V1 equals to P2 V2. Therefore, so dapat V2. So you just rearrange this formula. Your mathematics skills must be strong. Okay, P1 V1 over P2. And then what to do? So you just substitute the values that you have. What's your P1? 4P. Okay, times V1, 3 millimeter cubic over P2. What's the P2? PATM. You see, I wrote now I write the units. Why? Because so for if this is paper 3, paper 4 or paper 6, okay, I remember to leave the answer with the unit as well. So 4 times 3 is, okay, P kita cancel out, so 4 times 3 is 12. So no unit for this one. Okay, kita cancel, so we are just left with that one. Okay, so this is just to be careful lah if this is paper 4 ataupun paper 6. Okay, so for this one, the answer is 40C. Okay, so this is the correct answer, correct method to answer this one. Okay, right. Okay. Okay, so now 42. A fixed mass of gas has a volume of 25 centimeter cubic. Okay, fixed mass again. Alright, so this is about gas law. The pressure of the gas is 100 kilopascal. So we have V1, we have P1. The volume of the gas is slowly decreased by 15 centimeter cubic. Decreased by, okay, this is not V2. This is not V2, but V2 equals to 25 minus 15, which is 10 centimeter cubic at constant temperature. So again, I use this one. So this is also Boyle's law. Okay, P and V. Now, what is the change in pressure of the gas? Alright, so the question wants the change in pressure. So remember, it wants the change of pressure. So highlightkan this word. Okay, so what's the formula? We have P1 V1 again equals to P2 V2. So what's our P1? Okay, P1 is 100 kilopascal. Volume 1 is 25 centimeter cubic. Okay, P2 is the one what we want. Is the one that what we want. V2 is now 10 centimeter cubic. So P2 equals to 25 times 100. That gives us 25,000. 2,500. Salah. Okay, so I can cancel out the unit of the volume. So now that leaves us with kilopascal. Okay, and then 10 divided by 10. So that's easy mathematics, kilopascal. But okay, nampak macam ada kuat jawapan kat situ. But the question wants change in pressure. So this is the trap. Okay, students akan cepat-cepat jawab G, but the question wants the change. So what is the change? Therefore, change in pressure is, so you just minus off lah, 250 kilopascal minus 100 kilopascal. That gives us 150 kilopascal. Okay, right, don't make the mistake. Okay, this is a very easy question, but the mistake, you may experiment, an object is heated. The data from the experiment is shown. Okay, the energy transferred to the object is, so this is Q, and the mass of the object and 2 kg. The rise in temperature, so this is change in temperature. The specific heat capacity is 150 joule per kg per degree Celsius. What is the thermal capacity of the object? Okay, so the question wants thermal capacity, not the specific capacity. So what's the formula? So it's easy. So Q equals to change of data times capacity. So heat capacity equals to, so I better use the correct symbols. Okay, so C equals to Q over change data. So what's the Q? Q is 3 kilojoule divided by change of temperature. Degree, 10 degrees Celsius. So 3 divided by 10. That gives us kilojoule per degree Celsius. Okay, so that's kilo. So no answer in kilo, so you just change 1 2 3. So we have 3. Okay, we add how many zeros? So 2. So we have 300 joule per degree Celsius. So 47, the answer is B. Is that correct? Yes. Okay. Why didn't I have mass here? Kenapa mass tak ada? Because the question asks about thermal capacity, not specific heat capacity. If the question asks about specific capacity, so this is the answer. Okay. So 48. Okay. Figure 4.1 shows apparatus used by a student to measure the specific heat capacity of iron. The current in the heater is 3.8 amps. Okay. Now, the potential difference given. Okay, so we know now this is the current. This is the voltage. The iron block has a mass of 2 kg. That's the mass. When the heater is switched on for 10 minutes. So what is that? So this is the time. But time must always in second. Okay. So nanti we need to change the unit. The temperature of the block rises from. Okay. So this is the temperature change. Calculate the specific capacity. Okay. This is not that difficult. Okay. So specific capacity equals to this is something that you must remember. So Q, the energy change, K per unit, unit mass, and then per change of temperature to check. Okay. Now, do you have these values? If you have these values, you can just plug in the numbers. Okay, do you have Q? No Q. So this is our problem. So this is the problem now. Okay, the first problem is to solve this one. What is C? But now, in order to solve C, we need to solve what is Q. Okay, because the other variables we know already. Okay, now Q. What is Q? Q is energy. What energy? Q is heat energy. So when we know that, okay, is there anything that we can do? Now, given here, okay, we have given about current and then about voltage. What do you think? What is that? Okay, so actually you know the power. Okay, although there is no the power is not given directly. So how do you calculate power? Okay. We have V times I. Okay. But we want Q, energy. Okay, and then you know that power equals to energy over time. Okay, now we have energy in the, okay, we use symbol Q because now we have heat energy. Heat energy, we have special symbol which is Q. So from this equation, okay, okay, we rearrange, then that gives us Q equals to P times T. Faham tak? Okay. Right. Now, so this is solving what? Okay, and then we know that P equals to VI. So we substitute here. Here we put VI. And then times T. Alright, so what's V? V is 12 volt. I is 3.8 amps. T is but okay, and then you need to remember. So this one, energy must always in unit joule, usually in unit joule. Okay, so when you calculate power also, okay, you must leave everything in SI unit. So this one time is in 10 minutes. So we don't want unit minutes. Okay, we want it in we want this Q to be in joule. Therefore, we change 10 minutes times 60 seconds. So now the unit is in second. So that's why I wrote this, because that reminds me about the units. Okay, I must use. Okay, 12 times. Okay, now you have these values. You can just plug in the numbers. So what's the value? It's about 20,000, some 20,000. Okay, 12 times 3.8 times 10 times 60, 27,360. The unit I told you just now, joule. Okay, so that is not yet the answer. Okay, that is only Q. So now we substitute here. So 27,360 joule. Okay, per mass 2 kg. Mass and degree Celsius. So now change the temperature. Change in temperature 55 minus 25 degrees Celsius. Okay, so divide by 2. $456. Okay, what's the unit? Joule per kg per degree Celsius. But usually we don't write like that. We write like this: joule per kg per degree Celsius. So that's the answer. Okay. Alright. So usually in IGCSE we can round this off. Okay. Jangan, if you look at the answer schemes ataupun maybe ada options of answer, okay, jangan terkejut lah. So usually we'll round this off to 4, 5, or maybe 4, 5. It shouldn't be 450. It should be 460. Okay, if it's round off, joule per kg. Okay. Okay, last question I think. Okay, we have lots of other questions, but I don't think you pun ada masa nak buat banyak-banyak. So I should show a few other calculation question. So this one, 49. Figure 5.1 shows a plastic cup. The cup contains sand, an electric heater and a thermometer. The power of the heater. So here you are given the power, 50 watt, the mass of the sand. Okay, this is the mass. Now the unit is in gram. The initial temperature of the sand is 20 degrees Celsius. That temperature initial. The heater is switched on for 2 minutes. Okay, so that's the time. The temperature is recorded until the temperature stops increasing. The highest temperature recorded by a thermometer is 33. So what is that? That is the final temperature. Calculate the specific heat capacity. Oh, okay. So this is just the same with this one. Okay. So now, before I write, you say it out loud, okay, to yourself. Okay, in order to help your brain to remember more. Okay, exercise, brain exercise ni. Come on, brain exercise. Talk before I talk. Okay, so what you need to do? So the question 1, specific capacity. So you have done this one just now. Okay, so what's the formula? Okay, good. Q over M change theta. Okay, good. Now, next. Do you know Q? No, you don't. So what you do? Get from P. Yes, get from P. So how to get that? So P equals to... What do you have there? Do you know the power? Okay, and that, what's the formula for power? Q over time. So what? So you want Q. So Q equals to PT. So do you know P? Yes, 50 watt. Do you know the time? Yes, but okay, change minute into seconds. So that you are okay. So that you now your energy is in the unit of joule. So what's the answer? 50 times 2 times 60. That is 6,000. What's the unit? Joule. Okay. Pun watt second pun okay. So 1 watt second equals to 1 joule. Now, we substitute that value, 6,000 joule. What's the mass given there? Right. Okay, if the unit, okay, so this one, the question doesn't tell you what the question wants the unit to be in the final. Okay, so usually, if specific capacity, we want the unit in joule per kg per degree Celsius. So kg. Okay. So but this one is not in kg, so we need to change that one. So how do you change that? So that's easy. So 1000 you just, okay, 550 grams, okay, 200 kg, you just divide by 1000, so 0.55 kg. Okay, so here we have 0.55 kg times with temperature change 333 degrees Celsius minus 20 degrees Celsius. Okay, so 13 times 0.55. Okay, so kita ada 6000, oops, 6000 divide by, okay, 839. Okay, so the answer is 839. So how do you get this? You just use your calculator, jangan congak, per joule, per kg, per degree Celsius. If you want to round it off, ataupun if let's say you in the options of answer you don't see 839, so maybe they round it off to 840. Okay, so they round it to two significant figures. Okay, right. Okay, I think that's all. Okay, so all the best in your test. Okay, the test will not be that difficult. Okay, so whatever you have learned, that will be asked to you. Okay, right. So that's all for your, okay, this is all for the revision of this topic. Okay, HIT for IGCSE.